guys, welcome back for lesson 11.2 day 2. Today is a practice day for you guys, so you'll see that I'm asking you to do pages 7 and 8 in your packet. It is the 11.2 practice pages. I am going to just pick and choose a few of the more challenging problems to do on this video, but I'm posting my answer key for you to check all of your work. So check it. Text or don't text me, email me. There we go. Email me if you have any questions. And make sure you go on to the online textbook to do the homework assignment that will be graded for credit. Okay, so many of these problems you're going to be using the different formulas and working through them, sometimes working backwards to solve for pieces of information. The first problem I'm going to do with you is problem number 2. It's a population density problem because we didn't do one of those in our notes. So for problem 2, it says about 1.2 million people live in a region with a 6-mile radius. Find the population density in people per square mile. All right, so if you remember from the notes yesterday, we wrote in the vocabulary that the population density is equal to number of people divided by area of land. Okay, that was from yesterday's notes in the vocabulary. So here it's asking us to find the population density. So this is what we're looking for. Find the population density in people per square mile. And it says 11.2 people live. So that's the number of people. Not 11.2. I'm sorry, I read that wrong. 1.2 million. So 1.2 million is 1,200,000. 1.2 million people live in a region with a 6-mile radius. So we're thinking about the area in form of a circle since they gave us the radius. Okay, so if the radius is 6, to find the area of that circle, we're going to use pi r squared, so it's pi 6 squared. Okay, and then you're going to work through. We can simplify this a little bit before plugging it into our calculators if we want. 1.2 million over 36 pi. And from there, we can just divide, and we're going to get approximately 10,610.33 people per square mile. Okay. So that is problem 2 from the practice. All right, let me see which one we're going to do next. So the next problem we're going to look at is problem number 5. So for problem number 5, here is the diagram. This is J, L, K, and this is 125 degrees, 13 inches, and you have to point M over here. All right, so it says find the area of the darkened section formed by JLK. Now, I don't think the shading actually showed up on your packets. I'm not sure. I have to double check. But if not, you can look at my answer key first to see which region you're trying to find the area of. We're trying to find that right there. Okay, the area of that sector. So to find the area of the sector, you take the measure of the arc over 360 to find the fractional part that that sector represents. So it's going to be 125 over 360. And then you're going to multiply by the area of the entire circle, which is pi r squared. Pi 13 squared. Okay. So when you multiply 13 squared times 125 and then over 360 and simplify, kind of condensing and doing it all together, you get 4,225 over 72 pi inches squared. Now that would be the exact answer. If my directions asked for an approximation, that's approximately 184.35 inches squared. Okay, but that's the exact answer. All right, so that's problem 5. Let's work through problem 9. So for problem 9, you're given this circle here. Here's K, J, M, and point L, 40 degrees. You're told that this sector area is equal to 11.17 meters squared. And the directions are asking you to find the area of the circle. Okay, well, you might start by thinking, okay, in order to find the area of the circle, pi r squared, right? That's a formula that I need. But I don't know the radius. So if I don't know the radius, I can't use this formula. So then I have to think, well, what else could I do? I know that this sector area is 11.17. So I'm thinking about that sector area formula. Okay, so the area of sector is equal to measure of arc over 360 times pi r squared. Pi r squared, the area of the circle. So instead of writing pi r squared, I'm going to write area circle. Okay, so I'm going to use that formula. I'm going to use that formula and work backwards. The area of the sector is 11.17. The measure of the arc. Well, if this arc is 40 degrees, what's the measure of this arc? So take 360, subtract 40, and get 320. So 320 over 360. And then times area of the circle. Again, I'm leaving area of the circle instead of pi r squared because I don't know radius, so I can't plug anything in for that anyway. Plus, I'm trying to find the area of the circle, so it kind of makes more sense to leave that as part of the formula. So from here, I'm going to multiply both sides by the reciprocal of the fraction. So multiply this side by 360 over 320. If you want to simplify the fraction first, you can. Multiply this side by 360 over 320. And when I do that in my calculator and simplify, I'm going to have 12.57. So 12.57 meters squared is equal to the area of the circle. And that's that one. All right, I'll flip over to the back and pick and choose one or two problems. Okay, so let's see. Some area problems with shaded regions. Let's look at number 12. Number 12. So for number 12, you're given a diagram that is a square with a bunch of circles, 4 circles, 1, 2, 3, and 4, okay? And you're trying to find, by the way, they all have the same radii, put that in there. you're trying to find the area of the shaded region, which is this space all in. Okay. So if you can find the area of the square, and I know it's a square because it's labeled 10 by 10, and I think the units are centimeters. Centimeters, right? If you can find the area of the square, and then subtract away the circles, what you're left with is the shaded. So area shaded. All my markers are dying, guys. I gotta get new markers. Area shaded is equal to the area of the square minus the area of the 4 circles. Okay, so for area shaded, I'm going to first find the area of the square. It's a square, 10 by 10, 10 by 10, it's going to give me 100, right? And then I have to find the area of one circle and multiply it by 4. So I'm going to put the 4 there and then figure out the area of the one circle. That's going to go in my parentheses. All right, so let's work on that. To find the area of the circle, I'm going to use pi r squared. So I need to know the radius of the circle. All right, so if I have radius, here's another radius, here's another radius. So 1, 2, 3, 4, they're all going to be congruent to each other, and they have to add up to 10. All right, so what's the length of one radius? 10 divided by 4, or 10 over 4, right, would be one radius, which would be 2.5. So, or 5 halves. So 5 halves, I'll do 2.5 just to make it a little easier. These are all 2.5. Okay. So to get the area of the circle, it's going to be pi times 2.5 squared. Okay. So that is what I'm going to plug in right here. Pi times 2.5 squared. All right, so for this problem, I could ask you to leave your answer in terms of pi. Maybe I ask you to round. We'll do both. All right, so let's first find the area of the one circle. So I'm going to do 2.5 squared to get 6.25, and then multiply that by 4. That's going to be 25 pi. All right, so 25 pi is what this simplifies to. So if I was looking for the area left in terms of pi, it would be 100 minus 25 pi centimeters squared. If I'm asking you to round, which I might, plug that into your calculator. So I'll do that real fast. 100 minus 25 pi. And you're going to get 21.46. So it's approximately 21.46 centimeters squared. Again, it just depends on the directions. Make sure you follow the directions carefully. If the directions don't say to round, we should be leaving our answer in terms of pi. If you're not sure, you can always ask for clarification. Okay? So that's that one. I think the rest I'm going to leave for you guys to try on your own. The answer key is there for you to check. Let me know if you have any questions. And then, like I said, jump over to the online textbook and make sure you get your online homework done as well. All right, have a good day. Bye.